Hello, my name is Tucker Balch, and I'll be doing SQL and Analytics. I'm relating analytics with the sport of cross country, where hundreds of athletes race against each other in long distance races. These athletes and coaches need to keep track of the times they get, how well they do as collectively as a team, and how they would place among other teams. Using SQL with Analytics, you can track how well you do as an individual and how well you do as a team, which is what I'll show you today. So the first two tables I'll show you today are simple enough. This is the teams table. Each team has its own respective ID, a primary key. All these teams are based on teams I personally competed against in high school from Gwinnett County, and they each have their own coach name. So the next table is the athletes table. They too have a primary key. This is 50 athletes, and yeah, there's a foreign key right here, so that a foreign key from the team IDs table, so that each athlete has its own team that it's competing for. And all these names are randomized. These are not real people, just to assert that. All right, next right here, we need a race results table so we can actually add data and extract together results we need when analyzing performance as an individual or team. So I've added a results ID here as the primary key, the athlete ID, which is a foreign key right here, which references the athletes table, then a race time because we need the races, then a team ID also is a foreign key that references the team's names, and then we need an athlete name and team name so we actually know who's competing because every parent wants to see their kid's name up there. So let's go ahead and execute that, and let's see, it's already in there. Next we'll insert in some data. So in the first script here inserts in a bunch of random times. Here I'm showing all the attributes I want to enter data into and how they all reference each other's tables. But down here I am generating all the different times I want for each athlete. So I've used a stripe time to format it in this way: hours, minutes, seconds, 0, 0, 0, 0, and the absolute random function to randomize all the times from 15 minutes to 30 minutes because that's how usually on average a varsity athlete would compete in a 5K. And I've set that as race time, and I've also referenced the athletes and teams to their respective IDs. So let's go ahead and execute that. Select yes, and then on the race results we can see, yes, they go from 15 minutes all the way down to 30 minutes. So, but this isn't really what I want to show you. This doesn't realistically simulate an actual cross-country race. So as you can see right here, a team gets from 17 minutes to 23 minutes. So yeah, some teams are better than others, whether it's their team culture, their coach, or just pure luck. So I'm going to create data with adding actual realism to it, or just to have a little bit of fun. So yeah, let's go ahead and do that. Okay, so this is the actual script I wanted to show you guys. It gives a bit more realism when it comes to teams being better than other teams. So these are all the attributes I want to insert data into, but then down here I'm using this case expression to generate race times based on team IDs. I'm specifying that between 1 through 5 with the team IDs, that they get times between 15 minutes and 20 minutes. I'm randomizing it too. And then anything that isn't between 1 through 5 gets times between 17 minutes and 25 minutes. So these are the slower teams, and yeah, just be clear, there's nothing wrong with being on a slower team because I was on a slower team in high school, so there's nothing to be ashamed of. So then next I'm joining all the names and IDs together so everything matches up, and so then yeah, let's execute. Okay, so as you can see, when I organize it by team IDs, Team 1, Peachy Ridge, all has times between 15 and 20 minutes, definitely in range. And then when we scroll down to Team 10, they all have times between 17 and 25 minutes. And then next, when we order it, we can see all the faster teams, all the ones with 1 through 5 are all up front with maybe a couple outliers like Matej here, who is faster than a couple of the faster team members. So yeah, next I'm going to create a view to generate the team placements so we can see which team won the race. Okay, so in this script I'm creating a view to show which team won the race. I need to use the team ID and team name, and then this whole command right here just sums up all the race times, and then this rank command right here just ranks the teams based on their total time. So let's just go ahead and execute it real quick. Okay, so as we can see, Peachy Ridge has won the race by a very small margin right here. All the teams 1 through 5 are all 1 through 5, and all the slower teams are below. Okay, so the next two commands I'm going to create are two different races the teams will be separated into. They'll have slower times this time, as I will simulate a race where its course is tough, whether it's just hills or rough terrain. Okay, so this command right here is going to get all the teams with an even numbered team ID, as referenced here at the bottom. I'll create another race with odd number team IDs, which will be the exact same as this command. But just looking at this command here, I am retrieving all the data that I need from the other tables, but this command right here, this command will generate a new race time for each athlete, which will add any time between 30 and 90 seconds to their original race time. Then right here, I am just linking all the tables based on the athlete and team IDs, so let's just go ahead and execute. Okay, so as you can see, after executing the teams with an even number ID, you can see that Markin Jenkins got a 1605, and if we look right here, I just executed a query that shows he got a 1524, but he ran slower this time. So, but it's interesting if we look right here at Lars Jensen, who got a 1610. You just put his ID as 16, execute that, and he got a 15:20, which was actually faster than Marcus Jenkins beforehand, and he got a 16:10 this time, which he lost to Marcus Jenkins. So that shows that a course can actually make or break how you perform on a race based on how rough the course is. Alright, so the next thing I'm going to do is create another view which combines information from all the tables to provide a summary of both races for the athletes. So I've created all these left joins down here to retrieve all the athlete and team IDs from their respective tables. And then right here, I'm using this coalesced expression to simply combine both the even and odds race as into one column called combined race, just so we don't have too many null values when we separate it into two columns. And then this whole expression from time all the way to Unix Pox calculates all the athletes into an average time, and later I'll show you exactly what I'm going to use that for. And then this rank function down all the way to rank by average time, it just ranks all the athletes by average time. So let's go ahead and execute this and view the data. Okay, so I've created a table, and we can already see that Alejandro from Collins Hill is beating everyone in average times by a long shot. You can also view who got better race times by just clicking right here, and but what I really want to use this for is for queries, so let's do that. Okay, so right here, this query shows all the times from a specific team would get. Right here, I already have Collins Hill's team, but let's go ahead and change that to... Okay, yeah, we can see this query can be useful if any coach, rival coach, or individual athlete wants to see how they compare to other teams or how they compare to their teammates. So yeah, you can see that the query works. So this query just shows how an individual athlete would do if they ever just want to see how they're doing or how their friend is doing. So as you can see, I already have our Proteage Alejandro down here, but let's go ahead and pick a random number like 7 and yeah, Xavier Washington. So yeah, you can just pick whatever athlete ID from 1 to 50 and you can get results for that. Okay, so this next query will just show you a ranking of all the teams again, because every coach would need to know how they would place at a big meet and the culmination of all the race times they got. So let's go ahead and execute that, and you can see Peachtree Ridge is in first place. I believe they were in first place last time as well. So yeah, this is just useful to see where you place over in a district or how might you place against another team at a state final. Okay, for this script, I'm going to add one final race, and this is going to be called the district final. I'm going to retrieve the average times from the season race summary to calculate new times for this race. The difference from the last few calculations on race time is that it's going to randomly add or subtract any time from under to over 30 seconds to their average race time. This is going to simulate the psychological impact races can have on athletes. Sometimes athletes can have bad days or really good days, especially when they're under pressure during a district final. So with this, there's probably a good chance our Proteage, Alejandro, might lose this race. So let's go ahead and execute and see our results. Okay, so when I execute command, we see that unfortunately Alejandro did lose this race, and he actually got third. It looks like Gunnar Bowers and Marcus Jenkins came from behind and took his win. If we look at the comparing times query that I already made right here, we see that Alejandro definitely looked like he was supposed to win the race. He had better projected times than both Gunnar Bauer and Marcus Jenkins, but it seems like they just had a really good day today, and maybe Alejandro cracked under pressure. Let's go ahead and look at who won the race, which team won the race. I'm using the same command that I used earlier to calculate the winners, except I'm just taking it from the district final table. So when I execute that, we see that Peachtree Ridge, which was projected to win the race, lost to Parkview this time. So they too cracked under pressure and took the win. Okay, so I created one last view to add the district final to the final summary of all the times. It will essentially be a library which any coach could use for any mentioned reason they might want to. But if we look again, we see Alejandro is still a better athlete on average, but he was not as good as Gunnar or Marcus when it came to the final race. Also, this is one final thing to do. You can check which athlete, based on their athlete ID, all their times. Gunnar Bauer, for example, we'll just type in another random number, 26, Andre Miller. Yeah, you can just check any racer's profile, how they did, and yeah. Okay, so that concludes my presentation. Starting from the top, I showed how you can simulate different races considering the circumstances, whether that is because it is a difficult race or it is a district final where you can crack down under pressure. Next, I then showed you how you can view yourself as an athlete or your team to see how you're doing and how you can possibly improve in the future based on how good or bad you do in a specific race with these different circumstances. Next, the third one, I also showed how you can analyze the data to predict who might win the race. Obviously, as we saw, none of the people or teams predicted the win actually did win, and that happens all the time in sports, so it's important to simulate the things that could possibly happen. And finally, I showed an analysis of individuals and teams where I compared athletes to other athletes and how they performed over time and where they ended up. So overall, I hope you enjoyed this presentation and hope you have a good day.